You're listening to Impulse to Innovation. The Institution of Mechanical Engineers podcast. I'm your host, Dr. Helen Mees. As a global community of mechanical engineers with over 120,000 members in 140 countries, the Institution of Mechanical Engineers has been at the heart of the engineering profession since 1847. The institution's mission is to improve the world through engineering by sharing the latest news, views and insight into the creative world of technology and the people that make it happen. In this month's episode, we will be focusing on electric vehicles and batteries, the challenges and opportunities electrification brings and what the future holds for EV technology. I talk with Williams Advanced Engineering Technical Director Paul McNamara about the upcoming IMechE International EV Batteries 2020 virtual conference, which will be held on the 11th and 12th of November. Paul is chair of the event and shared with me some of the exciting topics up for discussion, which include the challenges of transport decarbonisation, battery cell sustainability and life cycle management of battery materials. My old IMechE policy colleague and now Stakeholder Engagement Director at the Advanced Propulsion Centre, Philippa Oldham, joins me to discuss her role in bringing together organisations from across the transport industry to develop innovative strategies for EV integration. She shares her thoughts on some of the latest EV technology developments and what to look out for over the next 5 years. And I speak with actor, fully charged host and passionate EV enthusiast Robert Llewellyn as we discuss the outcomes from Tesla Battery Day, the opportunities for vehicle-to-grid charging and the UK government's policy on electrification and EV city planning. Despite moving to a fully virtual setting this year, the IMechE's International EV Batteries 2020 conference is as popular as ever. The two-day conference hosts a myriad of experts from across the EV battery and energy storage community, where delegates will hear the latest developments in battery design, testing, thermal management and integration. Paul McNamara, Technical Director at Williams Advanced Engineering and Chair of the conference, took time out to speak with me about the importance of the event and what innovative developments we can look forward to seeing in the EV market in the coming years. Hi, Paul. Thank you ever so much for joining us on today's episode. I'm really pleased to have you here. Paul, could we just start by giving our listeners an idea about yourself and what you do and your involvement in the IMechE's International EV Battery 2020 conference?
Yeah, thanks, Helen. So Paul McNamara from Williams Advanced Engineering. So I'm a technical director here, and we've specialised ourselves in electrification over the last few years. In terms of the EV conference at the IMechE, I think it's the fourth or fifth year that conference has been run by the IMechE. I've been involved as part of the organising team for it, supporting the team at the IMechE, and have always chaired at least one of the days of the conference. It's certainly been one of those conferences that's built every year, and I think the consistency that the IMechE has shown in keeping it there and promoting it each year has really grown it as one of the most important conferences of its type in the UK at the moment.
It's not my field of engineering, so I didn't know much about the conference. So it's been really great to read up about what's been going on and see that it's been going for quite a number of years now, which is great. Now, I'm going to ask you a fairly obvious question next, I guess, for someone in your position. But for our listeners who are not that familiar with the electric vehicles and electric vehicle technology, why are EVs and particular battery technology and battery development so vitally important to society right now? I guess that's a big open question, isn't it?
Yeah, I mean, I guess, at a sort of obvious level, the decarbonisation agenda is a key driver for it. Now, it's clear that the direction of travel for transportation, as far as possible, is to move to low carbon sources. Electrification is something that is demonstrated, realisable, a growing technology and manufacturing base behind it. And also, whatever your persuasion with respect to wanting to use hydrogen or gas or whatever, all of those solutions have a significant element of electrification around them, because the electric drivetrain is a common to all of that, and some form of battery storage is a common to all of that. So the technology and the manufacturing that applies to it is important. Now, the headlines tend to go to passenger cars, consumer vehicles around this, but equally important is what we're going to do about commercial vehicles and off-highway, aircraft, all of these things. And again, whilst those won't become, not all of them will become pure electric means of transport, batteries and electric drivetrains will be an important part of all of that, coupled up with other technologies. So I think the sort of pioneering technology is being done in passenger cars. It's being, my own particular interest, obviously motorsport, we're very involved in that, and that drives a lot of technology, and that will flow out into many other sectors. That's the importance. In terms of what we're trying to cover at our conference, we're looking at the whole supply chain, how the cells are being manufactured in the first place, how that industrialization is coming about to support it, and how the government initiatives support that. But then moving on to recycling, control, charging, infrastructure, all these topics that go around electrification are also being covered in our conference.
Yeah, absolutely. I think it's important for people to recognise that it's not just the industry itself, but the supply chain as well. Everything that goes into the manufacture of those products, we have to be discussing in these kind of conferences. You mentioned actually about the conference running for a number of years, and there's a lot of big players who come from the world of EVs and energy storage, and they attend this conference. But from them, what are you hoping will be the highlights for you, and what are you looking forward to the most in hearing about at the conference this year?
Well, we've got, as we were saying, a big variety of different speakers there. So we've got new initiatives from companies like British Volt in terms of manufacturing of cells in the first place. We've got a nice section of 3 papers dealing with electrification in aerospace and how the needs for batteries as part of some form of a solution for aerospace is there, plus a good few papers on heavy duty and commercial applications. And that's all in addition to the bulk of it, which is around the more traditional light duty space, with various manufacturers of vehicles coming to talk about what their innovations is. And supporting that as well, some science-style papers looking at the next steps forward in chemistries and cell technologies that will come into the market in the future. So I think we've got a very broad range of things, and I'm certainly looking forward to the 2 days that brings together all of that. And you always tend to get a sense at the end of this conference about how all the different parts of the industry are coming together and what the trends therefore are likely to be over the coming years, as all the different actors trying to bring together battery technology and electric drivetrain technology will respond to challenges we've got.
Yeah, the electric vehicle market has been cited by the Advanced Propulsion Centre in their new report as critical for the post-pandemic UK, and they believe that it could benefit the UK's economy by £24 billion. And that's going to make some great opportunities for both the wider engineering sector, but also the automotive industries as well. What kind of technology developments are we expecting to see in the next 5 years, and what kind of future innovations will be on show at the conference? You've kind of touched on that a little bit, but I'd like to get much more of a sense of what we'll be seeing in the future.
Well, I think just to sort of echo your question a bit, in terms of the automotive industry or the transport industry in the UK, the electrification commercial impact and what the APC has said is absolutely right. I mean, we are a major producer of vehicles. We're a major producer of internal combustion engines. Those vehicles will need electric drivetrains for the future. And as we produce less internal combustion engines, we as a nation will need to produce more electric drivetrains. So it's key that we continue to push forward with our efforts there. In terms of the technologies that we will see, heavy-duty applications, which I think is a new engineering challenge for the industry as to how we're going to deal with heavy-duty. Does it have to be some sort of hybrid solution, potentially with hydrogen or something else, or can we see forward in pure electric vehicles? I think there's 3 papers dealing with that topic. We then have aerospace as well, and I think there we are looking at some papers again. I think it's clear to everybody that electrification is some sort of hybrid with other energy sources, and there's different thoughts on that, and there's also agnostic to what the other energy source is as to what have we got to deliver in terms of the electric batteries and powertrains. We have some papers on fast charging. Fast charging, I think, is going to become a key issue for the future because that's a usability of these vehicles, as well as the manufacturing. And then recycling is another key area because, of course, if we're putting this up as a low-carbon technology, which indeed it is, you have to take account of the whole life cycle of the manufacturer and the recycling. So all of those are covered, and I think, to anybody attending the conference, I think it will give a very rounded picture of where we're headed with that. I wouldn't want to sort of second guess at this point as to what the conclusions coming out from that will be as a sort of conference summary, but certainly what we've seen over the last few years at the conferences, I think in the discussion groups we have, and I think the conference is quite well organised so that we get discussion time as well to sort of try and bring together the views that we've heard and perhaps try and produce some consensus of a way forward as well. So I think that'll be interesting.
It sounds absolutely fascinating, Paul, and I'm very pleased to hear the discussion around sustainability of the products and the life cycle, and how you might address the sort of cradle to grave or cradle to cradle processes within dealing with the batteries. So that's really good news to hear.
Yeah, I think it is, and I think that's a key area where the industry has really taken responsibility for that. I think in this still relatively new push to create electrification, I think that's something that's been in there right from the start, is a sense that we have to produce a solution here that is sustainable throughout. And, I've seen a number of papers over the years looking at the amount of energy that goes into an EV versus a conventional IC engine thing. And certainly, quite a lot of work has shown that it actually requires a lot more energy to produce it. So we've got to show a payback that's effective, and we've got to show a recycling at the end of it, because I don't think anybody wants to see us just continually mining the sorts of rare metals that we need for our batteries without some means of being able to replenish that at the start of the cycle again.
Yeah, absolutely. I think that's a very important point to make. Paul, thank you ever so much for taking the time to talk to me today. I'm very excited about this conference. If anybody is listening and would like to attend, it's going to be on the 11th and 12th of November. Is that right, Paul?
Yeah, that's right. This year it's a virtual conference, of course, so even easier to get to than previous years.
Yes, that might encourage a lot more people to attend, which would be great. So thank you ever so much, and I really do appreciate your time to talk to us today. Thank you.
Thank you very much.
Philippa Oldham has been a leading voice in the transport industry for many years, both as Transport Manufacturing Policy Manager at the IMechE, where she produced a number of influential reports and articles on transportation, and latterly as Director of Stakeholder Engagement at the Advanced Propulsion Centre, where she leads a team who are challenging existing silos across the transport industry to help create strategies for innovative low-carbon propulsion solutions. I began by asking Philippa about her role as director. Philippa, congratulations on your recent appointment to Director of Stakeholder Engagement at the Advanced Propulsion Centre. Can you share with our listeners what that role entails and how that fits into the work of the APC?
Thanks, Helen. Yeah, really exciting. Thank you. All of it all-consuming as you can imagine. I suppose for the listeners, I'm not sure how familiar they will be with the Advanced Propulsion Centre, so I thought I'd just give you a little bit of background before I tell you about my current role and what that entails. But the APC set up in 2013 as a joint government, so Department of Business, Energy and Industrial Strategy and the Automotive Council, and so industry, got together to look at actually what could they do to really accelerate and strengthen R&D within the UK automotive sector. So it was formed in 2013. Lifetime was estimated at that point to be 10 years with £1 billion of investment. And so that is 50% coming from government and 50% coming from industry. Of that, they obviously set some targets because, we always have to achieve our targets, don't we? And that was about creating and safeguarding around 30,000 jobs and looking at the reduction of CO2 emissions by about 50 million tonnes. Now, what's exciting about this is at the end of last year, we sort of did a bit of impact analysis and looked at the projects that we funded and how they were performing, if you like, so went back on them. And actually what we found is we funded 113 different projects, and actually we've already safeguarded 40,000 jobs, so already 10,000 over the expectation, and we're projected to save 225 million tonnes of CO2, so way above that initial 50 million that was expected.
Fantastic.
And I suppose to put that into context, that's kind of sort of the equivalent of taking around 8-9 million cars off the road for their sort of whole lifetime emissions. So it kind of puts it a little bit in perspective, really. So I suppose predominantly that's what the APC is known for, is essentially being that funding platform. But we also provide insights. So we have we're sort of the custodians of the Automotive Council's technology and product roadmap. So this goes across the bus sector, the heavy duty and off highway and the passenger car markets, looking at the product developments and what we can expect to see in terms of their propulsion solutions out to sort of 2050. And then we also look around the technologies, so batteries, power electronics, electric machines, and again look at what potential targets should be, what potential European legislation is, and look at where the technology is going and the innovation is going to really help, if you like, steer some of that strategy. And I mean, of course, that's done by our technology trends team, so it's crystal ball gazing, if you like, especially out in those later years. So then it comes on to the spoke network, which are very much about bringing the community together, and that's kind of where my, I suppose, job before my promotion was looking after the spoke network, which are focused around the technology areas. So we have 6 batteries or electrical energy storage, electric machines, power electronics, 2 thermal propulsion spokes, or internal combustion engines, as many may know them, 1 around systems efficiency, and 1 around thermal efficiency, and then we have a digital engineering and test spoke as well. But really what they try and do is bring together academia, industry, government organisations, non-government organisations, look across the sectors, so they're not just auto focused, but run events and really look at those challenges and make sure that potentially research we're seeing in universities is relevant to industry, but also actually, and what's really exciting for me in terms of an example is thermal. We're both from engineering backgrounds and engine backgrounds, is that thermodynamics and thermal efficiency is a real challenge, or has been over the years with the internal combustion engine. And actually what we're seeing is similar with thermal runaway in batteries and in electric machines and power electronics. So we're seeing those individuals who have got those skills in thermal management and thermal modelling actually transferring their knowledge into those other technology areas. So it's a really interesting time for skill development, actually, in that side of it. So my current role is doing all that still. But I've also absorbed sort of our marketing and communications function as well. And really one of the things that we're trying to do at the Advanced Propulsion Centre is drive, UK ambition and UK resilience and growth, if you like, across the sector, and almost show how good the automotive sector is and the supply chain related to it to, either attract foreign investment here in the UK, but really champion about some of these organisations and some of the small businesses that, many have not heard of, and really look at how we can help them through their journey to, grow from initial startups potentially right through to hopefully larger, medium-sized organisations.
Yeah. Well, that's a really good point to make, Philippa, because your recent report on strategic opportunities in the passenger car electrification area, and you talk in that report, and I quote, "The UK already has the building blocks of a thriving supply chain and therefore provides a good backdrop for investments to meet domestic, European and in some cases global demand." Now, we don't often think of the UK as being a centre for EV and battery supply and manufacture. So can you tell us a little bit about the size and scale of that industry and where the growing market sectors are?
Yeah, so the UK produce around 1.2 million cars today, and we actually produce a lot of the luxury and premium vehicles. So Jaguar Land Rover, the Aston Martin, the McLarens, and actually with those vehicles they're going to require bigger batteries, and actually this gives us an opportunity to move the battery solution on faster than some of our competitors. But one of the things actually that we did a couple of years ago, and actually it's a bit of a prequel to this report, we started to look at the battery chemistry and what was required, and actually sort of thought, was anyone thought about engaging with the chemical sector? And so we did a bit of diving into that area, and actually we found that not a lot of engagement had happened between our chemical sector and our automotive sector. So actually we've helped bring those relationships together, and we found, for example, that in the UK we've got Europe's second largest nickel refinery that's already supplying battery producers in Asia. We've got one of Europe's largest lithium-ion battery production plants up in Sunderland, and we've also got Europe's largest automotive lithium-ion battery electrolyte plant manufacturer here. So it's really, you start to dig, don't you? And you suddenly uncover all of these different skills and companies and great organisations that you've had. And I suppose with the report, that got us a bit excited. And the technology trends teams that I mentioned earlier, and we started to think about, well, let's have a look at the global market. So, by 2025, global EV market is expected to reach around 97 billion. So we obviously then thought, well, can't be that greedy. So, address it back and scale it back to actually see what is achievable. And within that report and the analysis that we did, we found the opportunities around 24 billion of actually addressable market, and within that 12 billion of that is for the batteries, and the reason essentially that is for the largest number, if you like, is because of the cost of the battery within the vehicle. It's around 50% of the cost of an electric vehicle, so it's where the investment and where the innovation needs to happen, really. And so that's something that we've tried to focus on and really look at where those opportunities are. And within the report, we try and focus and highlight sort of 12 key areas, and much of those are around looking at the development of the key anode manufacturing, cathode manufacturing, but also looking at the resilience of the supply chain. So, for example, the magnets within the electric machines, currently we're 100% dependent on those permanent magnets coming from China. So actually, are there alternatives, ways, and actually could we potentially form a permanent magnet manufacturing capability within the UK, and we're doing a lot of research and studies within that. So we're hoping that with this report, it almost attracts companies to then come and bid for APC funding to address some of those challenges.
That's fantastic. It sounds very exciting. And it's not a field that I know an awful lot about. So to hear that all of that is going on across the UK and that we are really driving this forward, I think is a fantastic opportunity. As you mentioned about skills and people moving into other areas, there's great opportunities now for engineers to move into these sorts of fields. So that's really great to hear.
Definitely, and I think aggregation across the sectors as well. There's a real opportunity here as we decarbonise our transport sector for people to look at these technologies and see that they may traditionally have worked in auto, but actually there may be applications for rail or maritime, and again that's exciting for UK businesses.
Yeah, absolutely. Now, talking of CO2 emissions, obviously there has been a significant drive to reduce emissions over the last few years, and none more so than in the vehicle industry. The average EU-wide fleet targets for new cars will be 95 grams of CO2 per kilometre from 2021, and that's mandated to fall a further 37.5% by 2030. Electrification is currently the main commercially viable option for passenger cars that can meet these sorts of targets. Now, do you believe, and I know that this is a difficult question to perhaps examine, but do you believe the UK government is doing enough to implement these emissions targets, or do you think that they could be doing more to deliver on the electrification agenda? And what initiatives do you think we'll see coming out of Brexit?
Wow, that is the question. The government have currently got a consultation on their phasing out of the sale of new diesel and petrol cars. So we don't yet have their decision on that. Whatever the outcome of the decision, there will be some people that don't agree with it and some people that potentially do. But we know that it's going to be a challenge, as it always is. That's the whole point of targets, isn't it? Really, to try and accelerate the innovation. But I think what we need to make sure, and the ask is really to ensure that there's a consistency in funding and some sort of stability in the policy. Really, it's very difficult for companies throughout the supply chain to make investment decisions if policies keep changing, and so that stability is really important, and the continued long-term funding that comes down the pipeline that can help de-risk this development, like essentially the funding that we help facilitate, is really important to ensure that the sector stays strong. And the government is doing a lot in this area, particularly around the electrification agenda. In July, they announced an additional tranche of funding through the Automotive Transformation Fund, and this covers not only support for R&D capability, but also a tranche of capital investment. And to me, what's exciting is yes, that covers batteries, power electronics, e-machines, so all the fundamentals of electrification, but also it does extend out to fuel cells, because I think we have to be careful that we don't just go down one solution. We know, for example, yes, passenger car, as you've said, electrification seems the right solution, but actually for heavy duty off highway, those sectors, they're much harder to decarbonise, and actually electrification potentially isn't the right viable solution for them in the short to medium term. So we have to look at that broader perspective. But that fund is also looking at the breadth of the supply chain, but also taking into account recycling technologies. In addition to that, we've seen funding in predominantly in the areas of batteries through the Faraday Battery Challenge. So I think that was announced. I think it's about sort of 4 or 5 years ago now. But again, that was very much around the collaborative R&D activity, and they had the formulation of the Faraday Institution. So this is a number of key UK universities being brought together to really address some of those fundamental chemical issues and battery technology areas to see where they can make a difference. And also there's the formation or the building of the UK Battery Industrialisation Centre in Coventry. So that again is opening this year. I think it has been delayed, obviously, due to the current COVID situation, but it's now sort of open for business. And the whole area of actually the Battery Industrialisation Centre, it's there to help companies go and try their manufacturing processes and look at how they could scale up at volume. They get access to great bits of kit to see how it would work on their production line, look at the technology that they want to develop, look whether their processes are improving the system and becoming more energy efficient, for example. So it's really looking at how we can speed up the commercialisation of that battery technology. So that's again a great government investment, if you like, for industry to use. Alongside that, there's also the Driving the Industry Strategy Challenge Fund, Driving the Electric Revolution Fund, that was awarded last year for 80 million. And again, that's focused on power electronics, electric machines and drives. So again, if you think whilst you've got the battery there, you obviously need the control systems of the power electronics and the e-machine and the drives to sort of use the energy, if you like, from the battery to make it do something. Yeah. And that covers, I mean, again, that's exciting because that actually covers 7 sectors. So again, looking at where there may be spillover from one technology area or one sector into another to, again, hopefully advance some of these real innovative solutions to market as fast as possible. And I mean, the reason why I suppose the focus has been around, because it has been very heavily, swayed towards electrification, and there is no other option in due course, because of Dieselgate and the challenges that happened with the emissions coming out of our tailpipes and the recognition around that. Is that we do know that, there's an assumption that, 50 to 70% of new cars and vans, over the next sort of decade will have some significant levels of electrification. So actually these subsystems will be part of the vehicle, no matter how else it is powered. It might not be the full package, but it will be part of it. So then, just finally, I suppose, to go to your Brexit question, it's obviously difficult to say what initiatives they're going to put in place, but I sort of go back to that comment I started with, I suppose, that the funding remains stable, and it's important that whatever happens, that the UK is seen as a place for companies to come and invest in. I think the funding landscape, which I've just talked about, is part of that attraction, but also, we've got great opportunities for research and development here. We've got many of the world's renowned universities here, and it's about making the UK seem, have demonstrating, I suppose, the UK has the supply chain that some of those companies may want access to as well. So again, it's joining those dots.
Yeah, I absolutely agree. I think it's really exciting to hear the amount of funding that is going into early stage research. And one of the things that I think the UK is particularly good at is creating lots and lots of opportunities, lots of different pieces of research going on that kind of come together to solve bigger problems. And I think for me, that sounds really exciting. I think there's going to be some great opportunities there from a research point of view. So it's good to hear that.
Yeah. I mean, it's making sure we capture everybody, and plug in all those gaps, if you like, and understanding. But also, I mean, and again, this is where I think that the work that we've done around the prioritization, recognizing that we can't do everything.
Yeah, absolutely.
And I think, that's always important to think about as a business and a country.
Yeah, definitely. Now, we've heard earlier on in the show from Paul McNamara discussing the IMechE's EV Battery Conference that's coming up on the 11th and 12th of November. And there's some really exciting research that's going to be presented at that event. What technologies are catching your eye, Philippa, at the moment? And where do you think the next sort of big innovative breakthroughs are going to be made, particularly sort of across the EV technology market, I suppose, over the next 5 years?
Yeah, so I don't know if I've really got any sort of specific technologies, because there'll be movements in the cell chemistry and things like that, but I'm sure you'll hear about that at the conference. And I'm not a chemist, so I won't try to attend that. But to me, I think it's important that I think we've got a real opportunity at the moment to start actually shifting the way that we look at the way we design our products and the business models that we use. And to me, one of those really important aspects of this is we need to start talking more about sustainability, and not just that it's an environmental challenge, but also the social. It's a social and an economic one as well. And it's always a difficult conversation and a difficult topic, because we know, and I've stated several times within this interview that we're an international market. So how much can you really control in terms of this from a global perspective? But I think definitely from an environmental perspective, all businesses and everyone has the opportunity to make a difference. But to do this, I think we need to start businesses talking more about life cycle analysis and starting to use that as an important tool of their business, because this will start to unveil to them those possible trade-offs between, where they are having environmental impacts across the different life cycle phases of their product development. So everything from sort of the extraction of the materials through to the processing, through to the end life, and then the recycling and reuse side of it. And the reason why I say that I think this is a really important time now to take this on board is, let's learn from our mistakes. We became too focused, didn't we, on the emissions coming out of our tailpipe, and yes, the in-use emissions have been terrible, and it's great that was flagged. But, let's actually then take that holistic view now, because we know that producing batteries is very energy intensive. So, how can we ensure that they're being created using renewable energy and green energy, and encouraging those manufacturers to actually opt for a green manufactured battery cell, for example, rather than one that's made traditionally with, say, a dirty grid. And also, but then, where are those materials coming from? It's, there's a lot in the media. I don't have to go into some of the mining practices that there are around the world with some of the materials that are used in batteries, and indeed magnets and electric motors, and even power electronics, in all our phones. And these materials are scarce, and actually looking at how we extract them and how we reuse them is an important part of this. And that, principally comes from how we design something at the start of it. Are we thinking about how it's going to be recycled and taken apart at the end of its life, or actually are you going to put it into a second life? Are you going to repurpose it for something else? And understanding that value chain, I think, is a really important part of this. So to me, that whole sort of changing that principle of how we think about our products that we are designing and putting out there as engineers, we need to start thinking about that from the life cycle perspective. And I suppose coming back to where there are some really interesting potential technologies, I think maybe in the whole recycling processes, actually in the processing that we're going to see within that recycling aspect of it, and how can you get some of those critical materials back into maybe a reusable form, and trying to understand the value of each of our waste streams. Somebody's waste will be somebody else's primary source of energy or material.
Absolutely.
So trying to join some of those dots to really develop the ecosystem. Hopefully that can then help us build more localized supply chains for the greater good of the UK, really.
I think that's a really important area for engineers to be thinking about now. I'm very interested in the cradle to cradle process and the circular economy way of thinking. And so, I absolutely agree with you, Philippa. I think it's very important now for engineers to not just be thinking about the design and manufacture of the technology, but what they're going to do with that technology afterwards. So I think that's a great point to make for this particular subject. Philippa, thank you so much for joining us today. It's been an absolute pleasure to speak to you, as always. Thank you for sharing some of your thoughts on what we're going to be seeing, what's going to be coming out of this really fantastic industry over the next few years. So thank you very much for talking to me today.
Oh, delighted to be part of the series. Thank you very much for having me on.
There are many voices in the EV world who are keen to extol the virtues of the technology, and none more so than actor turned EV ambassador and host of the YouTube channel Fully Charged, Robert Llewellyn. Robert's show has millions of viewers each month, and he is passionate about educating consumers on an array of subjects which extend far beyond electric cars and enable them to, in his words, stop burning stuff. Robert and I discussed the outcomes from Tesla Battery Day, the importance of vehicle-to-grid systems, and barriers to EV technology adoption. But to begin with, Robert shares where his love of clean energy started. Hello, Robert, and welcome to Impulse to Innovation. We are delighted to have you on the show. Of course, many of our listeners will know you as the actor who played the very hard-done-by mechanoid Crichton from Red Dwarf. But obviously, you've had quite a fascination for science and engineering, I suppose, for a while. First as host of the long-running series Scrap Heap Challenge, and now with your own YouTube channel, Fully Charged, which all of us here at I2I are big fans of. So thank you ever so much for being with us today.
Well, thank you very much for inviting me. No, it's great pleasure and privilege to be here. Thank you.
No, you're welcome.
But you're right. Yes, I mean, I think my interest in science and engineering, particularly engineering, I think predates any work I did on television. I mean, certainly it goes back to my childhood. So, you know, I was constant. I had some of your very old listeners will remember this thing. It's called Meccano. So it was a mechanical construction sort of toy, I suppose, but quite an advanced one. And I had a second-hand massive, I think it was a set 10. It was the biggest Meccano set you could get that I bought from a boy I was at school with who didn't want it. And it was just amazing. And I would think it's possibly, I've still got one big box full of bits, which I would think is pre-war. I would say, if not, it was very early 50s it would have been made. So I was constantly building, you know, cranes and diggers and four-wheel drive gearboxes and I don't know, all kind of differentials. I remember making a differential. It took me days and it did work. It worked. I was so proud you know, all those things. So I was really interested in steering assemblies, things like that. So that kind of predated all that. And then as a sort of dropout hippie, I wasn't very good at being a sort of stoned, boring hippie. I wanted to do stuff. And so I did eventually, you know, I won't do the whole story, but I ended up living in what was effectively called a commune. It was just a sort of house of deep chaos in the Black Mountains in Wales. And we built, two of the guys who lived there built a wind turbine out of bits of junk, you know, literally like a scrap heap project. It was an alternator from a truck on a scrapyard, and we used, I think it was old dustbins we cut up and made the blades. I mean, this is supremely crude. I cannot overemphasize how crude this was, but it did actually work, and it charged a bank of 12-volt batteries in the kitchen with sort of bare copper wires all stuck to, I mean, really haphazard, extremely dangerous, I would think. But it did mean that we had lights in a house that at that time was genuinely off the grid. It had never been connected to the grid. It was in a valley in Wales. It had no electricity supply. So we had electric lights of a sort. You know, it's very post-apocalyptic, this place. But, you know, that was amazing. And of course, because I was, I think, maybe 17, 18 when I was there, right. I had no fear of heights. I climbed up this wretched, rickety wooden tower to oil the bearings, which were constantly seizing. I mean, the whole thing was, you know, very rubbish. But I've never forgotten that. And the fact that we used the wind in this valley to make electricity for ourselves and it didn't cost anything, it stayed with me. You know, I mean, I went off on loads of tangents, but that was definitely there. So when things like, I did a series for the Open University about engineering and science, and that led on to Scrap Heap. And Scrap Heap was like a dream come true, because this nonsense TV work that I ended up doing feels like by accident, it's never by design. You know, this was the perfect combination. It was wearing silly clothes, hanging around with brilliant engineers, watching people make stuff that was, you know, amazing, you know, and being an idiot, you know, it was just perfect.
It sounds perfect to me, actually. It's the kind of job I would definitely like. I think it's obviously something that's been very sort of close to your heart for a long time, and that's really nice to, you know, it feels like you're kind of an honorary mechanical engineer really here, I think. I really don't think I should be. I mean, I would have tried to struggle to convince people I was up until I did Scrap Heap, and it was after doing Scrap Heap for a few years I just went, these people are really good. You know, if I was faced with that challenge, I might be able to do so. You know, if someone said, you've got to build your part of the project is to build the steering assembly on this little go-kart we're making. If I had 6 months, then maybe I could do it. But, you know, they worked so fast. They were so creative. They would, I mean, you know, really put my skill set in perspective, basically, which is fairly low. I could do the drawings of it. That's what I'm quite good at. I can draw an idea like that and work out how it would work. But to actually make it is a whole other step. Well, one of the big points of engineering is not one person can't do all of it. So you have to have people with many talents and to work in a system to be able to solve a problem. So, maybe the drawing side of what you do would have been, the inspiration for engineers.
If Scrap Heap had teams of 20, I could be the drawer. I would be very happy to. I'd make the tea as well and make sure they're all right. No, I mean, I think that was it's a really good point, because the critical thing that we learnt over the years of doing that show was you could meet someone who was a genuinely, extraordinary, talented engineer, but if they couldn't communicate and work in a team, they would lose, and that we saw that again and again. It's quite often the slightly more average, maybe not so stupendously brilliant, but just fantastic team operators, people who worked in a team really well with the minimum amount of friction, the maximum amount of cooperation, would win because they just work faster and make a better thing. That was proven again and again and again. It's extraordinary how vital the sort of team dynamics were.
I think that's a great lesson to learn. I think our listeners will be nodding sagely at what you've said. Yeah. So let's talk about the work that you're doing now, obviously with Fully Charged and your passion for electric vehicles and for energy storage. I guess really my first question, Robert, is Tesla Battery Day this year.
Yes.
It's now become really a highly anticipated event in the EV calendar, and I can say that this year was no disappointment. Tesla are way ahead of any of their competitors when it comes to battery development. And they've just launched their new vision for their new 4860 battery, which according to them is going to be tabless. It's going to have a higher energy density than their existing batteries. And it's predicted to increase their vehicle range by 16%.
Yeah.
Now, this to me seems like an incredibly ambitious plan.
Yes.
What sort of impact do you think that this is going to have on the EV market over the next few years from the experiences you've had with what you've been doing? I
mean, I think it will. I think the general public are completely unaware of it, and I don't. And that I'm not saying that as a criticism. It's in a way, if you moved from a 4-cylinder car with 4 valves to 8 valves to 16 valves, 99% of people had no idea why or if there was any reason for it or anything else. But that said, I can only judge from the kind of the questions we get and the anxieties we hear. So obviously this year has been an exception, but I do an enormous amount of public speaking, particularly about electric vehicles, renewable energy, future of energy and transport. And the questions, which is always for me the most important part of those events, were always in the past range anxiety. People said, I'd have range anxiety. We're going to throw away the batteries after 2 years. They don't have the performance. There's nowhere to charge them. Those anxieties, which are all completely justifiable, have changed and some have disappeared. So one that's gone is range anxiety. People don't say that anymore. So I think the perception that the cars can go as far as you need them to go, essentially, has kind of worked through the kind of public unconscious in a way. So there's still anxiety about where you charge them publicly, and that's a hard thing to understand if you haven't used them. And you have somewhere off the street to park a car at your house, then public charging is kind of right down in the 5 or 10% of importance of your daily. You just won't use it. If you haven't got anywhere to charge, it's a different matter. But so those perceptions are changing. So this will, the fact that a car that can do, I have just done just short of 300 miles in a Tesla Model 3. I know people who've gone over 300 miles. I haven't managed it yet, but it is in the sort of 275 to 300 range is where you can drive. To add 16% to, you'll be good at this because you can do maths. What's 16% additional on 300 miles? I don't even know this.
Now you're putting me on the spot.
But let's go for an argument's sake with 350-ish. So if a car can do 350 miles on a charge, that is effectively 7 hours non-stop driving on British roads. The average speed when you drive on British roads, doesn't matter if you're on the motorway or A roads or whatever, is 50 miles an hour. So you can't, no human being, as I always say, it's not good for you. No human being can sit still and concentrate for that long. It's really bad for you. You need to stop. So my ridiculous argument is its bladder range, which I think is longer for women. I think women have an advantage here. And certainly for older men my age, my bladder range has diminished. So I have to stop way before the car. So I need a car that can top my bladder range, which is not a lot. 165 miles I did the other day, non-stop. I was really proud.
Right.
I think some people were slightly alarmed when they saw me punching the air when I got out and running for the jet. Didn't quite understand why it was. But so
yes,
those things, but the point, I think the equally, or if not more important thing about what Tesla are doing and the precedent they have, and they do have 5 to 10 years advance on any other car maker for sure, and also quite a lot of other battery manufacturers. But the important thing is longevity and cost and where the materials come from and what can happen to those batteries when they're no longer sufficient for a car. So all those things I think are critically important, and they are. What is so encouraging is they are being addressed. So there are amazing companies. We've already done a program about one of them in Germany that are recycling batteries. And they're getting 95+% of the materials that were in those batteries separated and able to be used to make new batteries. Now, however you argue the initial carbon footprint of manufacturing an electric car and the equivalent of manufacturing a combustion car, you can't recycle diesel. No one's worked out how to do that. You can't recycle fossil fuels. So the role that a car has is kind of completely different of an electric car. It is essentially a battery and a computer on wheels, an energy storage system and computer on wheels. And that's really where the picture, which I couldn't see that when I first went in an electric car in America 20 years ago. I had no idea. It just seemed weird. It seemed like a vacuum cleaner. Why would anyone bother? It wasn't like a proper man's car that made a noise. So I wasn't, when I first went in, I wasn't blown away at all. I mean, I was blown away by the performance because that car was very fast. And I was intrigued by it, but I wasn't sort of thinking, oh, that's the future. It took me years. I was very slow to come around to the understanding it. But that opens up the whole, the sort of thing I start off by saying is electric cars won't save the world, because they clearly won't. They're not the answer to everything, but they will open a door to allow us to understand the energy, if you like, the energy matrix we live in and what we consider normal. And it starts to put a slant on what we consider normal. And what we consider normal is going somewhere remote, drilling a 2-mile deep hole in the ground, pumping out a black toxic liquid, refining it at an enormous energy cost, which is never put into the calculations, enormous energy cost, transporting and refining, and then burning it for a few milliseconds in an inefficient combustion engine. Then you go, that is bonkers. That's stupid. and that's really what I think that whole movement of the sort of electric car industry, and it's personified by Tesla. And I think I always want to say Tesla existed before Elon Musk. It wouldn't exist now if it wasn't for Elon Musk, because he made it what it is today, but he didn't invent the cars. But he knows how to find clever people that will do it for him, which is a very important role.
That's definitely true. He's a very good leader from that point of view. Well, that kind of leads us on actually to vehicle to grid charging technology. You talked about obviously the bladder distance, which I think is a great unit of measurement. For those of our listeners who are not familiar with V2G, it allows users to save or earn money by using their EV batteries to store energy and discharge it back to the national grid when it's most needed, say sort of peak demand during the day. Now, this kind of sounds to me like a win-win for everybody, Robert. You've got a renewable source supplying to the grid and a low emissions EV vehicle. However, there's very few electricity companies that are offering V2G at the moment. And even those that are, it's kind of dependent on where you are in the country, really, from what I can understand, and what EV you have as well. The other more critical problem is maintaining the grid balance as well. So do you see V2G and energy storage as a whole being successfully integrated into the national grid? And do you think that the national grid's ready for the increasing surge in electric vehicle demand over the next few years?
I mean, I can only answer that from what I've been told by the engineers who run the national grid, and I've had a lot of conversations with them and interviewed them many times.
Sure.
And I mean, they don't even hesitate. They don't go, well, we're kind of getting close to it. No, they're ready. It isn't a problem. They're very keen on it. It will actually help them. And that's a kind of a hard thing to understand. But what they want is the perfect world for the national grid to operate the most efficiently it could is that we all consume exactly the same amount of electricity 24 hours a day.
Yeah.
That would make their lives very easy. And we really don't. And so anything that mitigates the enormous peaks and the enormous troughs in demand, it really helps them to balance the grid. So if they can call on that energy that, say, was stored in 5, 10, 15 million electric vehicles, and we're talking gigawatts of potential power there.
Yeah.
They don't need much from each individual car. It might only be a kilowatt hour, 4 or 5 miles range. It's not like you're draining the battery. It's a little trickle from each one, but because there's so many of them, and once that's integrated into a grid, and that doesn't put a massive strain on any one particular part of the grid, because if you think, say you've got a housing estate with 250 houses, and there's 150 electric cars plugged into those houses, when those cars are charging, that power is going into those cars.
Yeah.
And when probably at a higher rate. And when they're discharging, it's coming out. Well, it's going along the same wire, just goes the other way. And it will be less, I would say, when they're using vehicle to grid, because it will be a variable amount they're pulling. So it could be quite a small amount sometimes. So from what I understand, this is my understanding of what I've had explained to me. And as for it will be a slow take-up, I think. It will take a few years before it becomes a common thing for a domestic household. It's not instant, and I'll explain a few of those reasons. But where it's clearly going to kick in very quickly is fleets. So, for instance, Amazon in this country are just taking the first of, I think it's 2,500 electric vans. Now, they have big 100-plus kilowatt-hour batteries in them. They are fitting vehicle-to-grid systems in all their warehousing, because they can make money. It's as simple as that. They're not doing it to be green and tree hugging. They're doing it because they get, there's someone high up in Amazon in America. In America, they've ordered 100,000 electric vans, which they're taking delivery of at the moment. And that if you have 100,000 vans plugged in and you can sell the electricity that's in them at a critical time of the day when you're not using them, obviously, then you make money. That's the reason why they're doing it. And then they can buy electricity, obviously, at incredibly cheap rates at night or when they're not being used. And that helps balance the grid. So it is that's what will drive it is not a greenwash, eco-credential, press release with a man leaning on the vehicle-to-grid charger outside the bank headquarters. They'll go, oh, gee, we can make a load of money out of this.
Yeah.
And I've seen so I've been to an office in Tokyo, which had, I think, 40 of their employees. It was a company that works with Nissan. So they all had Nissan Leafs. And at the end of the day, each of the people who owned those cars were guaranteed they had enough to get them home and back to the office. So they had a buffer.
Right.
They would set that. But then all day, that office had solar panels on the roof and a solar parking, so a canopy over the cars. And it was charging and discharging those cars constantly. And at the end of the day, they had enough juice to get them home. Yeah. And that was the kind of and that the electricity costs in Japan are very different. I couldn't really understand it when they explained that, but they've had a 70% reduction in their office running costs because of that.
Wow.
So they're not selling power in that particular instance. They're just using it to run the office. And that's clearly a benefit. So that was all the air conditioning, all the computers. And it was a big office and it had big servers, it had an heavy duty energy use.
Yeah, yeah.
So that stuff is amazing. But then quickly to get back to the only technology at the moment, because this was developed in Japan many years ago. So the CHAdeMO connectors for your listeners that don't know about electric vehicles, and why should they if they don't have them, but there are two common high speed, or as they're called, rapid charging connectors. The European standard, effectively it's becoming now, is called CCS, and it doesn't matter what that's like. And then the original Japanese version was called CHAdeMO, and that's a slightly different protocol, slightly different plug. And of course you can't plug, it's like early mobile phones, you can't plug a CHAdeMO into a CCS and vice versa.
Yeah.
But the only system that allows a two-way electricity at the moment, bi-directional, is CHAdeMO. So I have a CHAdeMO vehicle to grid charging unit at my house here, which is an experimental one, and and so you can only plug it into a few cars. Mitsubishi's, any Japanese electric cars originally would have had it, or a Nissan Leaf. Can do that, and they are built to be able to send it. So at the moment, it's very limited to that. But what is changing, and that unit is very expensive. No normal human being would put that in their house, unless they're a complete idiot like me. And I didn't have to pay. This is an experiment. I did not pay for it because it is thousands of pounds. But what's being developed now is a Type 2. So if you're driving along the motorway and you stop and you charge on a rapid charger, that charges you at 50 kilowatts to now 350 kilowatts, a lot of energy. If you go to a car park at a supermarket and there's a little socket and you plug into that, that is 7 kilowatts. That's much slower. That's adding like 20, 25 miles range in an hour.
Right.
And that's what you would have at home. Well, it's that system. So it's called Type 2 in this country. A Type 2 charger, which is common across really the whole world, particularly anywhere in Europe has those chargers. That will only be able to take roughly 7 kilowatts out of your car, which is not that much, but it's enough if there's 10 million cars, and that is cheaper. And we're going to have to wait until that technology is common, so that when you buy the car, it's already got it in. It's part of the hardware in the car. The car actually needs some hardware as well as software to allow that bi-directional charging. But that is where it's become much more plausible. I saw vehicle-to-grid systems probably 8-9 years ago, but they were phenomenally expensive, massive humming boxes in corporate car parks where, the head of PR would say, we're really proud that we're running this office 1% of the energy in the office off this electric car. So it's come a long way in that time. Yeah. And once you can have Type 2 bidirectional charging, it just makes sense for anyone who's got an electric car. I mean, I think the critical thing that you understand once you've got an electric car is you don't use it very much. I've got an electric car here. I'm not using it. What's it doing? Nothing.
Yeah.
Why aren't I using it? Why am I putting electricity in from my solar panels, because it's bizarrely suddenly gone sunny now, or using that electricity to run my cooker and washing machine? So I mean, I can do that in my house because I've got batteries as well. I've got Tesla Powerwall, so that has shown me the huge advantages of this technology, because my electricity bills from April, so early April this year till very recently, till the end of September, were under £10 a month. And I run 2 electric cars. I run one electric car just off solar and 2 other electric cars off any electricity that we can get. So I'm a really heavy electricity user. And if you can run 2 cars and have an electric house, which we have, electric cooking, washing, all that stuff, water heating, and you were only paying £10 a month, then
that's fantastic.
I know I am an overprivileged, tree-hugging, eco libtard. I'm just going through the list of things I get called on Twitter. But, I'm really proud that I've done that in my old age. And as my son, who's 27, pointed out, I know when Dad carks it, that's an Australian term for dies, we'll get nothing because he's spaffed it all on renewables. Which I thought I had to write that one down because it tickled me.
Yeah.
He's not entirely right, but he's close to right.
But at least he knows you've been, environmentally sustainable in the process. There's absolutely no reason to talk about my family, but it is a wonderful turnaround with my son, who was. His father and son had a difficult adolescence. I'm not going to lie. We went through some tough times, but he's an amazing lad now. He's really good. And he's a vegetarian. He rides bikes. He thinks internal combustion cars are the work of the devil. He hasn't lived at home for 10 years. So it's not me entirely, it's his mates. Yeah. It's that generation, I think. Well, maybe as you said before, Robert, your experiences of living off grid and so on, maybe he's kind of following in Dad's footsteps. So that's not a bad thing.
I just hope he doesn't hear this, because if he hears, you're following in Dad's footsteps, then he's immediately become a massive petrol head.
I'll make sure I edit that out. No worries.
Yes.
Now, talking of sort of families and homes, I've been really excited to see you've launched the Fully Charged Cities 2020 competition. Now,
yes,
this is a great way of not only highlighting the importance of electric vehicles and clean energy usage, as you've been talking about, but also to give communities across the UK the chance to share their personal renewable energy success stories. So, to what extent are you hoping to develop this competition? Do you see it as being an opportunity for local governments, councils, business leaders to share best practice and also to develop strategic EV city planning opportunities, for example?
Yeah, I mean, absolutely. So, I mean, it has certainly been, we were so excited about it in January and February.
Yeah,
and it's certainly kind of it's hovering. It's still going, and we've had amazing response to it, but there's no question. I think, currently local councils, in whatever form they take around the world, are slightly preoccupied. Which is absolutely understandable. But I mean, it is very much a global thing. So we've had applications from, Singapore and New Zealand and Australia. So it is not just a UK based thing. I mean, it is in a sense partly driven by our audience. Our audience on Fully Charged is now 27% UK. So the rest is the rest of the world. So I'm amazed because I didn't think of that when we first started it.
Yeah, that's incredible.
So, I mean, I think it's a really a critically important thing to kind of highlight and celebrate the amazing cities around the world that are kind of often acting independently. I mean, America is a fantastic example. We were in Austin, Texas earlier this year because we did our last live show just before the lockdown was in Austin, Texas. And I think of Texas completely, and not wrongly, as an oil-funded, very, very conservative, if not reactionary, slightly terrifying state where everyone has more guns than you can poke a stick at, blah, 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 all the normal cliches. And I saw elements of that are true, but in the cities, so the urban triangle, they call it, which is Dallas, Fort Worth, Austin.
Right.
Those cities are some of the most progressive in terms of their energy use, their transportation policy, their electric buses. They have electric scooters are mandatory. They have lanes for them. They discourage car use. They have car-free day, combustion car use, car-free days. Amazing amount of stuff. Huge solar farms and a massive wind capacity. So it's Austin's aim. It's to be 100% renewably powered by not long, 2025. They're talking about for the whole city and all the industry. And now the Tesla factory is being built there, which is why we knew that was going to happen. Why they're going to build it in Austin, because they've got the workforce there, the education, the backup, and support from local government to do that. So Tesla are building. They've already said it will be the biggest. I bet it won't, but a truly colossal solar farm on sort of scrubland that's a few hundred miles from Austin. They will be doing that kind of scale of renewables to run the factory. So, what is, again, going back to Tesla, it's fantastic that when they say we're going to have this huge factory and people go, oh, it'll just run off fossil fuels, they have gone the extra 100 miles to go, no, it won't. It's wind and solar and battery storage. Because when you're talking gigawatt hours of usage every day, it's an enormous amount of energy. So those stories, I think, are really important. So we've done a bit about Dundee, which is amazing in Scotland, what they're doing there.
Yes, I saw that episode of the show, yeah. And
they put in charging hubs, which are now just starting to appear. We're about to go and see a really big charging hub that is being nearly finished. All that stuff. And what I love about that is you see this big commercial company developing this huge charging hub, and they could just buy the power probably quite cheaply from any of the big power suppliers. And they're going, no, we're not going to do that. We're going to use our own solar. We're going to buy wind power, and we're going to do this, and we're going to have massive batteries. And that's the whole point of this, is otherwise there's no point doing it. And I always get encouraged when it isn't me as a sort of whinging observer going, oh, I should use solar panels, because I don't know if it's really possible. And then you meet people who run commercial companies that have to make money, that have to make a profit, have to survive, and who understand the technology. And they go, no, we're using solar. Yeah. We can do it. That is fantastic. So in a way, that's what drives the whole of the Fully Charged. Definitely, I just saw the account yesterday. It's definitely not making money. That's definitely not why we're doing it.
No, that's not why we do this, because we're passionate about the subjects that we talk about, obviously.
But I mean, clearly, well, I'm sorry, the reason I mentioned Austin, that was the whole point, is that you can have a government that is incredibly hostile to this stuff and a kind of populist, that is the case in Brazil as well. There's amazing stuff going on in cities in Brazil we don't really hear about, and we're trying to make sure we can get something covered on that.
Yeah.
But you have this very hostile government. The city authorities, all the city authorities in America are following the Paris Climate Agreement, even more so now after Trump just pulled them out. So it's actually galvanized more activity, strangely, than was happening under Obama. Far more. I mean, they really. But it's also a combination. It's a combination of politics and the technology. The technology has become plausible and affordable, and is increasingly affordable. So Las Vegas is hugely solar powered now. All the casinos have massive solar arrays on their roof. I mean, on a scale we can't imagine in this country. Gigawatts of solar. Because one of the roofs I went on is 14 acres.
Goodness me.
That's a roof. And it's all covered in solar.
Yeah.
And huge batteries. I mean, really kind of, multiple containers in the back, down the back with fans humming.
Yeah.
Amazing.
I mean, that leads me on to question, really bringing us back to the UK, having heard what's going on in other countries. Yeah. The UK government has just announced £20 million of funding for schemes designed to increase the uptake of electric cars. Yeah. And around £12 million of that apparently is being spent on battery technology research. Yeah. This was announced on the 9th of September on World Electric Vehicle Day.
Yes.
By our Transport Secretary, Grant Shapps. And he said, this, together with our continued support of R&D, will see talented UK-based SMEs flourish, as well as the creation of 6,000 skilled jobs, which is great news for the EV industry. It's great news for the supply chain, as well as being obviously a much needed cash injection for UK's universities and some of the research centres that are working on EVs. Yeah. But do you think this is a good step forward by the government in driving the electric vehicle agenda? Or do you think they could be doing more to implement the technology adoption and particularly the infrastructure that goes with it? And in what way do you think that they could improve on that?
Those are brilliant questions. I mean, I think, I'm anxious. I think it's a really good thing. And obviously they could do more. But I think there might be, the innovation I'm seeing in this country, very specifically in this country, is around kind of energy management software. The kind of because we used to have obviously we were one of the world's leading car manufacturers in my father's time, so most people's grandfather's time, a long time ago. And that has really diminished, and I'm very anxious about its survival now. Like from next year on, I think it's touch and go whether we will have anything that resembles a car manufacturing base here, and that you kind of need that background to we need, if we were producing amazing electric cars by the thousand here, that would be amazing. But that is many billions to invest to get a factory like that going. As Tesla is a very good example of that. But there are so many other aspects of the technology that are related to it. So, to develop the technology, so cheaper, lighter batteries are more common material. So, and it is happening here now. And I just worry that this sort of focus on vehicles, because it's something that a politician can go, look, we've made these wonderful electric vehicles. And I just worry that we don't have the capacity to commercially produce, we're talking millions of electric cars, not a few hundred to have a photograph with. What Volkswagen have done in their Zwickau factory is billions and billions of euros investment to convert a huge pre-existing factory. It's where Trabants were made because it's in what was Eastern Germany. It's a really big factory. They've converted it so it runs entirely off renewables, and two, they're making hundreds of thousands of cars a year electric. They only make electric cars there, and that is a massive, colossal investment. Well, we've got nowhere like that here now, and we've got no company in this country that is like that. But we have amazing skill set of people who are developing chargers that just use your solar power, chargers that know what time of the day to take the electricity and put it in your car. And those are selling overseas. That's a lot of it is not hardware. A lot of it is software, which is annoying for engineers. But then there's other aspects as well, which I think are really important. And it's when people say electric cars in this country, I get slightly depressed, because if they said electric vehicles, hello, we have amazing capacity to make, a rival amazing company just up the road from me in Banbury, are making commercial vehicles, electric commercial vehicles. Well, their electric commercial vehicles will be better than anything that Vauxhall or VW or Renault make in terms of vans, because they're not trying to convert an existing van that doesn't have the proper shape to be able to have a battery skateboard under it and really take advantage of the technology. And they're starting from scratch, and they're using different materials to make the panels, blah, blah, blah. And they are doing really, really well and having huge orders coming in. So that is a massive success story. Electric buses we should be making, electric trucks we should make, electric earth movers. I'm very grateful now that JCB are finally starting to produce electric earth movers, which JCB, huge employer in this country, supplies stuff all around the world. And they are working out, I see, if we have a 8-ton battery electric digger, it's actually cheaper to run and maintain than a diesel one.
Yeah.
Like, not a little bit cheaper, hundreds of thousands of pounds a year cheaper. And they're working out that is a sellable product. I had an electric digger here. It was fantastic. There's no way I could make it run out. It's the opposite of bladder range. It was focus range, that was. Because I just went, I've dug all day. I've dug a really difficult trench. I'm exhausted. And the battery was 3/4 full. I've been using it for 6 hours. So they're really adequate. They work. And it was so much nicer to use than a diesel digger with an engine going all the time. It was virtually silent. It's amazing. So that technology, I think we've got a great advantage on. So, and then it goes much further than that. Then hydrogen fuel cells, shipping, all that stuff. Flight, the stuff we're doing in aeronautics is amazing. That whole area. And then of course wind turbines is the other one. In that technology, again, a curse, because we don't really have a big indigenous manufacturing base for those turbines. But at least a lot of the technology is being built here, even though it's owned by Danish, German, American and Norwegian companies. They're doing very well out of our wind. The Danes are doing extraordinarily well out of Britain's enormous wind success. But it's still brilliant.
It is, definitely. Well, Robert, thank you so much for taking the time to talk with me today and to express your passion for this subject. I think we're going to get a lot of questions from our listeners over the next few weeks as they listen to the show. So once again, thank you ever so much for talking to me today. It's been a pleasure.
Thank you. Well, thank you for inviting me. It's been great. Thanks very much.
That's all for this month, and indeed for this year. We'll be taking a break through December to recharge our batteries and to prepare our exciting schedule of episodes for 2021. We will be covering topics across a wide range of engineering subjects, including railways, space, brewing, and even a live streaming episode from Formula Student. But just in case you need an I2I fix between now and January, I will be having a Christmas fireside chat with our very own CEO, Dr. Colin Brown, and President Terry Spall, as they share their IMechE highs and lows of 2020 and what the IMechE can look forward to in 2021. So why not follow our podcast on your favourite podcast player or on our host site to keep up to date with our latest releases? Details can be found in the episode notes. You can contact us via email at podcast@imeche.org or leave us a comment and a like. So until next year, from all of the team here at Impulse to Innovation, stay safe and keep on engineering. You've been listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. Thanks for listening. We'd love to hear from you, so if you'd like to share any news or any feedback with us, then please email us podcast@imeche.org. All the information on this episode can be found in the episode notes.